Today's lesson is very similar to the last lesson. We're going to be looking at the number of ways that things can happen. We're going to learn 2 shorthand notations for some types of problems today. So the first question says, 12 skiers are competing in the final round of the Olympic freestyle skiing aerial competition. In how many different ways can the skiers finish the competition, assuming there are no ties and also assuming that anybody that makes it to the final round could, in theory, be the winner? So there are 12 places we need to give out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So assuming there's no ties and assuming that anybody who makes it to the final round could, in theory, be the winner, how many people could be the winner? Any of the 12. Once somebody has won it, how many people could come in second place?
11.
And third place?
10.
And so on and so forth. On down until somebody has to come in last place. Okay, now it's last place in the final round of the Olympics, so it's hardly a last place, right? But still, somebody has to come in last place. We could type this all into the calculator, and it's not that bad. It's not that many, but what if, like, there were 50 people, right? That would get a little bit annoying to have to type it in all the way down. So we have a notation for this. When we start at a number and multiply by every number below on down until 1. We stop at 1 because if we multiply by 0, everything gets really boring then, right? Multiply by 0 and everything becomes 0. But if we multiply by a number on down until 1 with every number in between, we have a notation for this that looks like an exclamation point, but it's not like 12, right? It's called a factorial. So, I mean, you can say it like that. It makes math maybe a little bit more exciting. But we don't just read that as a really excited 12. We read that as 12 factorial, okay? And what 12 factorial means is start at 12 and multiply all the way down until you get to 1, okay? Your calculator has a button to do this. It's a little bit hidden, so I will show you where to find that button. If you are working on a graphing calculator, quiet down please. If you are working on a graphing calculator, what you're going to do is type in the number that we're working with, 12. And then to find that factorial, you're going to press the math button, which is right underneath the alpha button. And we are going to use our over button to get to the menu titled PRB, which stands for probability, because that's what we're doing. And choice 4 is our factorial. So we do that, hit enter. And this tells us there are 479,001,600 different outcomes for this Olympic event.
What do you want the answer to be? Like,
I want the 479,001,600. Yep, and when it actually worked out. Quiet, please. If you are working on a smaller scientific calculator instead of a graphing calculator, usually there's just a button on there that says PRB, and then it would be right in there. If you're working on an iProduct calculator, which is fine to do for your homework, but not the test, of course, there is a factorial button on it when you turn it sideways to get the expanded calculator. So that is there to use on those as well. Okay? So actually work it out. Don't, as your homework answer, don't give 12 factorial, but actually give what it is when it's calculated out, the 479,001,600. Okay? The part B of this problem says, in how many different ways can 3 of the skiers get medals? Because really, that's what it matters, right? Who remembers, like, 4th place, except for the person's mom, which they're very happy. I would be very proud of my child for getting 4th place, but still nobody else remembers who got 4th place. So we really just care about 1st, 2nd, and 3rd place, right? So 12 people could win, 11 people could then get silver, and 10 people could get the bronze. And we're going to multiply that out. That is very similar to what we did in the previous assignment. And we would get 1,320 different ways that the medals could be awarded in that event. Yes?
So, like, what if you had a really long one, But it didn't go to 1, it went to like 3.
Good question. We will get to that in future examples. Yes.
So when we're using the calculator, do we have to go find that button every single time?
Yep.
Or we could.
Yep. You just kind of have to keep going back into the math menu and getting it over and over. Yep. Number 2. You have homework assignments from 5 different classes to complete this weekend. In how many different ways can you complete the 5 assignments? 1, 2, 3, 4, 5. As I'm looking at the 5 textbooks sitting out in front of me, I could choose any of them to do first. Then once I have 1 done, I could do any of the 4, 3, 2, and something's going to get done last. Okay. You could also write this as 5 factorial then, since we're starting at 5 and multiplying on down to 1. On this one, I mean, depending on how quick you are going through those menus, it might be faster to just type in 5 times 4 times 3 times 2, and you don't even have to type in times 1, because that doesn't matter, right? So it might be faster to just multiply this out than go get that factorial.
It's basically the same thing we did yesterday.
It is very similar to the last lesson, yes.
Oh yeah, sorry, right. My bad, guys.
For part B, in how many different ways can you choose to do 2 of the assignments, something first and something last? We don't care about the middle here. So I'm like looking at my 5 books, I'm like, all right, where am I going to start? Because starting is the hardest part, right? It's like getting the motivation to just begin. So choosing how you're going to begin, and then which one are you going to procrastinate until the last? Which, by the way, here's a little study skills topic for you. Whatever your weakest subject is should not be your last homework assignment. Okay, it should be like first or second, because as you do homework, your brain gets tired. And if you save what you're worst at for last, now you're doing your worst thing while you're most tired. That's not the best plan. So just a little free study skill topic for you. Whatever happens to be your worst subject, human nature is to procrastinate it and not do it, but it really should be more towards the beginning of your list. So anyway, we got 5. We're going to choose how we're going to start this, how we're going to end it. So how many things could I do first? 5. And once I've decided what I'm going to do first, how many could I decide I'm going to do that last? 4, not 1, because I'm not worrying about those middle ones right now. I'm looking at my 5 books and saying, okay, I'm going to start with this, and this one I'm going to set to the side, and that's my last priority. Okay? Should probably be the thing that you're best at. So you got 20 different ways that you could make that decision. All right? In the next example, you're considering 10 different colleges. Before you decide to apply, you want to visit some or all of them. Because when you apply, a lot of times you have to write an essay, which is a little bit of a pain, and often there's an application fee. So before deciding whether you really want to go through this application, you might want to at least see, is this a school I might be interested in? So part A says, how many different orders could you visit 6 of the colleges? So I'm going to 1, 2, 3, 4, 5, 6 places. I'm interested in 10 schools. So how many could I visit first? 10. And second? 9. Keep on filling in the blanks, which brings us down to 5. So we could type that in the calculator, right? Or we have a shorthand notation for this as well, which answers Nick's question from earlier. What if we're multiplying all the way down, but we don't go all the way down till 1? We stop somewhere before. This is what's called a permutation. Okay? Our notation for this is that we put how many total options we have, and then a big letter P for permutation, and then how many are we selecting? We're selecting to go to 6 schools in this example. So this is our notation. The formula at the top tells us another way we could calculate this. That what we're doing is saying 10 factorial would be if I was going to every school, but I'm not going to every school, so I want to divide out what am I not doing. I'm not going to 4 of the schools, because I am going to 6 of the schools.
That makes sense.
Okay, so you have 3 different ways that you could choose to enter this into your calculator. You could just do the multiplications out, okay, which might be the easiest way for you to go about this, is to just type in those multiplications.
That's what I'm
There's a permutation option in the same place that the factorial was, except not on an iProduct. I'm sure there are free apps that you can download that will do permutations for you, but the built-in calculator doesn't have one. So then you might want to do the 10 factorial divided by the 4 factorial is another way about it. So on the calculator then, different ways of doing the problem. I could just do 10 times 9 times 8 times, oops, that's not a 9. 8 times 7 times 6 times 5. Okay, I could just type it all in. Or I could do the permutation thing. To do the permutation thing, you type in your first number, 10, go into that same menu, math, over to PRB for probability, and option 2 is that permutation, and I'm going to 6 schools. I get the same answer. Or I could do the 10 factorial divided by, I am not going to 4 schools, and then factorial. And that gives us the same exact answer. Okay, so any of those 3 ways to enter it into the calculator is fine, whatever way you feel most comfortable with. Okay? Questions? The part B of this problem says, what if you actually want to go to all 10 schools? Then what would we do?
10 down to 1.
10 factorial, 10 times 9 times 8 times we're going to every single school, so this is 10 all the way down to 1. Again, you could just type that all into the calculator, or you could go grab that factorial, and that would tell us then that we have 3,628,800 different orders in which we could visit those schools. Some of these orders would make more sense depending on like location. If 2 schools are right next to each other, it makes sense to visit those 2 at the same time. But that is how many different orders we could do it.
Not the 7, but the
Okay. There are 12 books on the summer reading list. You want to read all or some of them, and how many orders can you read 4 of the books? So 1, 2, 3, 4 choices I'm making. For my first choice, I could choose any of the 12 books. 11, 10, 9. And you could just type that in and that would give you the answer. Other options. How would I do this as a permutation? 12 and then 9. Okay, how many I'm actually choosing? No, 4, sorry. We're not choosing 9, we're choosing 4. Because that was the last number there.
Oh.
So 12 of them and we're choosing 4 of them. Or we could say 12 factorial would be what if we're reading all the books, divided by how many are we not reading if we're reading 4 of them? 8 of them. Okay? Any of those 3 things would be fine to type into the calculator. You should get the same answer for any of them, which is 11,880. So you guys have far more than 12 books on your supplemental reading list, and you always say that you don't have enough choices, but clearly you have a lot of choices, you just don't like the choices you have, right?
Yes.
But you have a lot of choices.
I recommend the samurai. No.
It's true. Think about orders, yeah. You still have a lot of choices, but yeah, orders make it a lot more. Part B. Part B, what if you're actually going to read all 12 of them? How many different ways could you read all 12? What would we do here? The full factorial. That will give you exactly the same answer as question number 1 about our skiers, because in that one we had 12 skiers. So we get exactly the same answer. Oops, too many zeros.
Well, you get half credit if you say a lot.
Yep. No, you'll get no credit. Sorry. No credit. No credit for a lot.
I don't know the answer, guys. Just say a lot. It's worth half.
Good try, but no. Last type of problem. One more type of problem to look at. This is a little bit different than the previous ones. In the previous examples, each of the things we were placing in order was a unique individual. So there are 12 unique individual people in that skiing competition. Okay? There are 12 unique individual books on that list. There were 10 unique colleges to visit. Okay? So there we're looking at unique things. Here we're looking at where we have some repetition. The way I think about these problems is like Scrabble or like Words with Friends where we have that shuffle button. Okay? And we want to shuffle around our letters. But if I have several of the same letter on my tray, I might not notice a difference when I hit that shuffle. It might have actually shuffled it, but all it did was switch an E for another E, and I can't tell the difference. So our question here is when we have things that are exactly the same, how many different shuffles or rearrangements can we do where we could actually see a difference? Okay? So like if I had the Scrabble tiles, O-H-I-O. One change I could make is just swapping the two O's, but nobody would be able to tell that I had done that, right? So our question is, how many different ways can I rearrange it where somebody could actually see a difference in it? Our rule here is we're going to take the number of things that we're rearranging, so for Ohio, 4 tiles, factorial. Divide by how many times each of those things shows up. Factorial. So O shows up twice, factorial. H shows up once, and we do a factorial, and I shows up once, and we do a factorial.
Does there need to be a space in between those?
There does not need to be a space. If you type them right side by side, the calculator will know, but I would not bother typing in the ones because 1 is just 1. It doesn't actually make a difference. So when we type this in the calculator, I would just do 4 factorial divided by 2 factorial, which is 12. You cannot in any way combine factorials. So it is very tempting for students to, in a problem like this, and 4 factorial, 2 factorial, to divide and say that that is 2 factorial. That is not true. Okay? There's no way to easily combine those factorials together. Okay? You just actually have to do the 4 factorial divided by the 2 factorial. Okay? Don't try to do arithmetic on those numbers. So there'd be 12 different ways I could shuffle those tiles where somebody could see a difference in them. Mississippi has a whole lot more repetition in it. So what we need to do first is determine how many letters we have in the word. There are 11 letters in the word Mississippi. Then how many times does each of them show up? If it's a single, you don't really need to worry about it, because that would just be 1 factorial, which is just 1. It doesn't matter. So M, we don't need to worry about, because it doesn't repeat. I repeats itself 4 times. S repeats itself 4 times. P repeats itself twice. There's no easy way to combine those, so don't make it like 10 factorial or 32 factorial. Don't try to add them, don't try to multiply them, don't try to do anything. But you do need to put parentheses around that when you type it into your calculator. Otherwise, your calculator will divide by the first thing and multiply by everything else, which is not what we want. We want it to divide by all of that.
If there's no matching letters, you just do the factorial.
Yep, if there's no factorial, it would just be divided by a whole lot of 1s, which wouldn't make any difference.
Okay.
Yep. So to type this one into the calculator, I'm going to do the 11 factorial, and then divide by, in parentheses, 4 factorial, and then you don't need to like type any times or anything like that. The calculator understands that. Another 4
24 times 40.
factorial, and another 2.
Size parentheses is 24 times
factorial. And then close up the parentheses. 34,650 different ways we could shuffle up that word and be able to see a difference.
Wow.
That's crazy.
Okay?
So you have to run.
You have to do the parentheses, yes. Because otherwise the calculator will divide by just the first thing and multiply by everything else. We want it to divide by everything. Okay? All right, and last one, same type of problem here. So for the word summer, which I believe will come someday, 6 factorial. S doesn't repeat, U doesn't repeat, M has 2 repeats, E doesn't repeat, R doesn't repeat. So we just get 6 factorial divided by 2 factorial, which is 360. For B, waterfall has 9 letters in it total. A repeats itself twice and L repeats itself twice and nothing else. And once again, don't try to combine those in any way. Don't make them a 4 factorial or anything like that. It doesn't work. It's not true.
It's 4 total.
It's 4 total, yes, but it's not 4 factorial. Make sure to put parentheses around that. 90,720 for that word. Okay. Your homework is from the same exact worksheet as last assignment. So it's still the 12.1 part of the worksheet, still that front page of the homework packet. Make sure you notice we got some multiples of 3 in there. And then the copier cut off the copy of problem 61. So you can't actually read what 61 asks you to do. So I guess that means that you get to thank the copy machine and stop at just number 60 instead of stopping at 61 because you can't read 61.